Yes, students, now in this video I will explain you a concept of escape velocity. Escape, the literal meaning of escape, to get rid of something. Escape. Actually, suppose we are under the effect of some other body. If we get rid of that binding, that's the escape. So what is the meaning of escape velocity here? It is a point, very important point here. When we throw any body vertically upward, it goes to certain height and then return back to the ground because of gravitational pull of earth. Larger the velocity given to body, greater the height, and it is still return to the ground. But if we give the velocity of body so that body goes beyond the pull of earth, does not return back, just go beyond the pull of earth, then that velocity is called escape velocity. So I can say here simply the minimum velocity given to a body the minimum velocity of body given to a body just to go beyond the gravitational pull of earth. Gravitational pull of earth means body goes beyond pull of earth and then it will come to rest, then it is the minimum. If we give some more, then it will continue to move. Minimum velocity given to a body just to go beyond the gravitational pull of earth. You know, gravitational pull of earth is at infinite distance. So that infinite word confuses. But when force of gravitation becomes negligible, like we have some mass, but we are unable to attract other body because our gravitational pull is negligible. And we know gravitational potential energy of a body of mass m on Earth's surface is given by U is equal to minus Gm upon Re, where Me, mass of Earth, Re, radius of Earth. U is equal to minus Gme upon Re, where M mass of Earth, R radius, M mass of body है भाई. We know that gravitational energy of body of mass M via M, mass M on Earth surface, on Earth, पता नहीं क्या लिखा गया. So mass M on Earth surface is given by this, and potential energy beyond the pull of Earth, and the potential energy of body, of any body, just beyond the pull of earth, zero. Pull of earth means no force of gravitation act on the body. So actually to throw the body up, we have to do work. If you place any body from the ground to certain height x, you do the work mgx. So in carrying the body from the surface and send to beyond the pull of earth, work is done. So minimum work done to send a body of mass m beyond the pull of earth is equal to increase in potential energy. Initial was the u initial on a surface minus g m e m upon r e, and u at infinity was 0. So it will be zero minus g m e m upon r e is equal to g m e m upon r e. Now, how can we do this work? This work is done in the form of kinetic energy. This work done will be equal to the kinetic energy given to body to send it beyond the gravitational pull. You might be thinking the same thing is being repeated again. Now we have to explain what is happening there. So if VE be the escape velocity, then half mv square equal to dme m upon re. This is that velocity which is given to throw the body beyond the pull of earth. And there it will come to rest. If velocity more than this, body certainly will go out and continue to move. After this it will not move. Now m cancel. So VE square equal to 2GME upon RE, or VE equal to under root 2GME upon RE. Now we know that GME upon RE square is equal to small g. So GME upon RE is equal to GRE. And hence V equal to under root 2 GRE. G is the accelerated gravity. This is the formula also for gravitational, escape velocity from the surface. It depends on G and radius. As you know, value of G on our surface keep on varying from one place to another. Radius also is not same everywhere. So escape velocity will depend on position. Now, if you use G equal to 9.8 meter per second square and R is equal to 6.4 10 to the power 6 meter per second, then BE will be under root 2 into 9.8 into 6.4 10 to the power 6. Decimal remove किया तो it will be 2 into 98 into 64 10 to the power 4. This is 64 under root 8. It is 196 root 14. So 14 into 8 into 10 to the power 2 meter per second. 14 8 is 112. 112 into 10 to the power 2, or it is 11.2 10 to the power 3. Or simply you can say that V is equal to 11.2 kilometer per second. Per second. So if we throw any body, it is independent of mass of body. Escape velocity does not depend on mass of body. And its value, whether you throw mass of 2.5 kg or 0.5 gram, escape velocity same for all bodies. Escape velocity same. It depends upon G and RE. It depends on mass of Earth. Gravity, larger the mass of planet, the greater the escape velocity. Lighter the mass, minimum the escape velocity. You know, there is no atmosphere on Mercury. Actually, you will learn in kinetic gases. Gas molecules are in random motion on our surface. I am in the room here, air is silent, but molecules are in random motion. And that velocity is called root mean square velocity, VRMS. That is under root 3 RT by M. M is the molecular mass, T temperature. So at Mercury, temperature is very high and mass of Mercury is small. Mercury, it is the closest planet to Sun. So there, because of less mass, escape velocity has small value. Because of high temperature and the light mass of gas, root mean square velocity will be higher. And at the planet where root mean square speed of air molecule greater than escape, the molecule of gas escape the gravitational pull of that planet. Are you getting me? Mercury, the smallest planet and closest to Sun. Due to small mass, it has escape velocity from its surface less than 11.2. Because of nearest to Sun, temperature on this is very high, and that's why every gas escapes from the pull of the gravitational pull of the Mercury. Then Venus is there. Venus, Mercury, Venus. Venus has atmosphere filled with CO2 gas. Because mass, root mean square is dependent on mass, heavier the mass of molecule, smaller the root mean square speed. So again Venus is closer to Sun, so it is surrounded by CO2 gas, and due to CO2 temperature it is much higher than it should be there without this. So by knowing the escape velocity, we can determine the presence of atmosphere on any planet. Now, what will happen if the velocity given to body more than escape velocity? Then body will go beyond the pull and continue to move and will not stop. There is a question here in our book. Escape velocity on Earth's surface is 11.2 km per second. What will be the velocity of the body if it is thrown with thrice this escape velocity? What is the velocity of the body beyond the pull of Earth if it is thrown with thrice the velocity from the Earth's surface? Have you got my question? By BE on Earth's surface is 11.2 km per second. If velocity given to body, velocity given to a body is equal to 3b, then what will be the velocity of body beyond the pull of Earth? How to solve this? Actually, the total kind energy hogi by it is the Earth here. We throw it, goes beyond pull of Earth. So to send beyond the pull of Earth, energy required equal to Gm upon Re, which is equal to half mv square. As velocity. But here velocity is thrice v. So some energy left, that will be the form of kind energy. So here, applying law of conservation of mechanical energy. We have here half mv square. It is the total energy given to the body. Here V is equal to thrice V. I will write later on. Is equal to half mve square. This is the energy required to go beyond the pull. Or plus half mv dash square. V dash the velocity with which body will move beyond the pull of Earth. Here half m cancel. It is thrice of 11.2 into 10 to the power 3. Yeah, kilometer and a square is equal to it is 11.2 square plus v square. So v square equal to v square equal to 9 into 11.2 whole square 3 का whole square और minus 11.2 whole square. It is 8 into 11.2 whole square. It is b square. So b equal to 8 under root 8 into 11.2. Root 2 means 2 root 2. 2 root 2. 1.414. 11.2. You can multiply it. This meter per second will be the velocity of body beyond pull of Earth when body from the surface is thrown with thrice the escape velocity. So don't think that when we throw the body up with the escape speed, then it will continue to move. The kind energy given to it will be used only to go beyond the pull of Earth, and then body will come to rest. So I think you have got it, this topic. I will do some numerical again on this topic, and then I will take later on orbital velocity.